All right, let's get right into it. If you've ever found yourself just completely lost, trying to figure out what's going on inside a serverless application, you are definitely in the right place. Today, we're talking about the solution you've been waiting for, OpenTelemetry. I mean, it's the question we've all screamed at our monitors, right? You build this amazing, super efficient, auto-scaling app, but the second something breaks, it feels like trying to find a ghost. It's there 1 second and gone the next. And here's the crazy part. The very things that make serverless so awesome are exactly what make it a total headache to monitor. Things scale up and down on their own, which is great, but the instances vanish in a blink of an eye. You've got cold starts messing with your latency. And there's no server you can just SSH into to poke around. It's a completely different ballgame. So, here's how we're going to tackle this. First, we'll pinpoint exactly what this serverless blind spot is, then we'll see how OpenTelemetry unlocks that black box. After that, we'll get practical and look at setting it up on your cloud, figure out how to keep costs down, and then we'll peek into the really cool self-healing future that this all makes possible. Okay, first things first. Let's really define the problem we're up against. We're calling it the serverless blind spot. That huge gap between what's actually happening inside your functions and what you can, actually see. Now this is the aha moment. Look at how perfectly OpenTelemetry, or OTel as you'll hear it called, solves each problem. There's no machine to scrape metrics from? Fine, just embed the OTel SDK right in your code. How do you follow a single request when it's hopping between a dozen different functions that are scaling up and down? That's what context propagation is for. It's like a passport that gets stamped at every stop. And my favorite parts? No more vendor lock-in, and with distributed tracing, you can finally see the entire journey of a request from start to finish. It's like turning the lights on. So we've identified the enemy, the blind spot. Now let's talk about our weapon of choice. It's time to really dig into the key that's going to unlock this serverless black box for us. So what exactly is OpenTelemetry? Think of it as a universal language for your applications to describe what they're doing. It's a single, open standard. You instrument your code just once, and then you get the freedom to send all that juicy data, traces, metrics, logs, the whole shebang, to whatever tool you want. No being locked into a single vendor's ecosystem. And the way it works is super logical. Step 1, your function code, now with the OTel SDK inside, is creating all this telemetry data. Step 2, it sends that data off to something called a collector. Now this part is technically optional, but trust me, you're going to want to use it. Finally, step 3, the collector processes and shoots that data over to your backend, whatever you're using, Jaeger, Prometheus, you name it. Okay, the theory is cool and all, but let's get our hands dirty. How does this actually work in the real world, on the cloud platforms we're all using every day? And of course, we have to start with the big one, AWS Lambda. It's the platform most of us are on, so let's see how they handle it. Spoiler, it's surprisingly easy. And I'm not kidding, it really is just 2 main steps. First, you add the official OTel Lambda layer. Think of it like a pre-built package of everything you need. Second, you just set a couple of environment variables to tell the function where to send its data. And that's basically it. You're up and running. But what if you're living in the Google Cloud world? Well, let's hop on over there. You'll find the story's pretty similar. For all you Python folks on GCP, this is going to look super familiar. It's literally just a pip install away. You pull in the packages you need, and then in your code, you just initialize the exporter and tell it where to go. It's clean, it's simple, and it slots right into how you already work. And let's round out the big 3. How does Microsoft get this done with Azure Functions? Azure has some really tight native integrations. You can actually configure things like your data sampling rates right inside your host.json file. It makes connecting to Azure monitors super smooth. But, and this is key, you're still not locked in. You always have that freedom to send your data anywhere else you want. So, if there's one thing to take away from this section, it's that middle column. Just look at it. Full support. AWS, GCP, Azure, they are all in on OpenTelemetry. This isn't some niche little side project. It's a first-class citizen fully supported on the platforms you're building on right now. So, we're collecting all this incredible data, which is fantastic, but we also have to pay to store and analyze it. Let's talk about how to be smart and keep those costs from spiraling out of control without losing the visibility we just gained. This is where sampling becomes your absolute best friend. Look, in dev, sure, capture everything. But in production, that's just not practical. You want to use intelligent sampling. A really powerful way to do this is called tail-based sampling. This means your system waits until a whole request is finished before it decides whether to keep the trace or not. Why is that so cool? because it lets you keep 100% of the traces that have errors while only hanging on to a small slice, maybe 2 to 5% of the successful ones. You get all the important info without the massive bill. Okay, so you have all this data flowing in. What do you actually put on your dashboard? Well, here's a great starting point. You've got to watch your cold start time and your function duration. Those directly impact your user's experience and your wallet. But don't stop there. Keep a very close eye on invocation errors. Watch your concurrency so you don't get throttled. And, this is a big one, monitor the latency of any databases or other APIs your function is calling. This is how you turn a flood of data into real, actionable knowledge. We've shined a light on our blind spots, we've gotten a handle on our costs, so what's the end game here? What's the ultimate potential? Let's look at the incredible future that all this rich telemetry data starts to unlock.
And this is where it gets really cool. You take that rich, structured data from OpenTelemetry, you combine it with smart automation, and you get what people are calling AIOps. But forget the buzzword. Imagine a system that doesn't just alert you that something is broken, it tells you the root cause automatically. Or a system that sees a traffic spike coming and scales up before it hits. A system that can literally fix itself using event triggers. We're talking about building a truly self-healing architecture, and it's all powered by this amazing data.
And that really brings it all home, doesn't it? This is the core idea. When you use a standard like OpenTelemetry, especially in the serverless world, you're not just collecting data anymore. You're building a system that can understand itself, that can react, that can predict. Your telemetry stops being just data, it actually becomes intelligence.